Hello, this is one more question like which had appeared in the examination. So about the general quadratic formula. Basically, when we are talking about the quadratic formula, we just want to estimate the area under the curve. Like for example, this is an integration a to b f of x dx. Now here, if I relate this f of x dx with my question, so my f of x happens to be e to the power ex. Okay. So the general quadratic formula that we are going to apply here is basically it is actually hard to draw the curve. Okay, so instead of doing it geometrically, what we do is we use the procedure of numerical integration. So we have a base formula for this. The base formula, okay, that is the mother of all these Simpsons and one third rule and trapezoidal rule is the general quadratic formula. General quadratic formula. Quadratic. So this general quadratic formula, if you look at the general quadratic formula, this is basically it is used to find integration of any particular function at specific points, basically to estimate the area. So here in like let's see, this is the area, this is the region. A to B is the region wherein I have to find the function and its integration. So this is approximately given by h, okay, w naught f of x naught, which can also be in some books, this is represented as y naught, f of x naught, okay, plus w1 and f of x1, or f of x1 is nothing but it is same as y1, okay, so don't get confused, and so on and so forth, yn and f of xn, which can be also written in terms of this. Now here you see this h is the spacing between the points, okay, this is the spacing between points, so it is given as b minus a divided by n, the value of a. That is the upper integral minus the lower, okay, integral. And here again, your x naught would be equal to a power, sorry, x naught is the first function that is equal to a, and x1 is equal to a plus h. Similarly, x2 is equal to a plus 2h, and so on and so forth. And the last value xn is equal to b. So here only, this is the base general quadratic formula. And here, the other things that x naught and w naught. What are these things? Basically, W naught acts as a weight. Okay. So here I'll tell you here H is the step size. Okay. Step size. And this values W naught, W1 up to Wn. Okay. These are the weights. Okay. And your X naught, X1 are the points. X naught, X1 are points. Okay. At which we calculate, which we calculate f of x. Calculate f of x. Now, in this particular problem, it is given like this 0 to 1 e power x dx. Okay, this is given. Now, if you go back to the general quadratic formula, or in short, to the trapezoidal rule, okay, so if you need to derive this trapezoidal rule from this formula, trapezoidal rule, so we will see that, okay, let's consider 2 points first. Let's consider, okay, 2 points. One is your x naught, let this be equal to your a, and another point x1, let this be equal to b. And we know the step size is basically b minus a. Okay, as from geometry, what do we know? Geometry, we can say that area under a straight line, okay, under a straight line between any 2 points line, between 2 points can be estimated, between 2 points can be estimated as a trapezium. Okay, trapezium. Okay, a trapezium is basically nothing but a slanted rectangle. Okay, a slanted rectangle. Now, what is the formula for the area of the trapezium? Formula for this area of trapezium is C. So it is half of first height, right? Let's say the first height to be height of 1 plus height of the second half okay, into the width. Okay, so f of x naught value here is basically height at x equals to a, and f of x1, which is the y1 second point, is height at x equals to b. So, and definitely the step size acts as a width. Step size is your w, which is the width. Now, if you just want to locate these points together, so you can directly write a to b f of x dx, basically area. See, now this is a single integration point right here. So it will give you area, right? For example, if you have x of x into dx, it will give you x square by 2, right? Answer plus c. If it is not definite, but here the limits are mentioned, right? So if the limits are mentioned, this constant does not come. So it will come as a x square by 2. So it's a square function, so it gives you area. Similarly, here also, this integration will give you the area. Single integration, okay, it gives you the area. Now, same thing here. So the area would be equal to, if you calculate height of f of x naught, right, which is the x naught is the point that is corresponding to a, plus f of x1. X1 is the point which is corresponding to your b value. So this is the rule that you can apply here. Now, in general, for multiple intervals, multiple intervals from the general quadratic formula, what you have to do, see, now if you consider points like, for example, let me say x naught is equal to a, okay? Another point is x1 is equal to a plus h. Same way, x2 is equal to either x2 is equal to x1 plus h, or it is a plus h, right? X1 is a plus h. So this is a plus 2h, correct? Similarly, your x3 is equal to x2 plus h, or it is a plus 2h, which is nothing but your x2 value, right? x2 is a plus 2h plus h. So a plus 3h. And so on and so forth, up to, you can go this value up to xn, and xn value would be equal to b. Now, if you want to just apply it into the formula, so this formula, a to b f of x dx will become equal to, this will be, this is derived as h of 2 f of x naught plus twice f of x1, right? And up to the value of, okay, x of n minus 1, this will be, these sides will be 2 times twice f of xn minus 1 plus f of xn. So in short, how do we represent this? In short, what do? I write a to b. So now the two values common up to x of n minus 1. Here you see this up to here. So in short, I can write this as a to b f of x dx, and this value to be equal to h by 2 f of x naught as it is. This I can put a summation value. I can start the summation from I is equal to 1 to I is equal to n minus 1 f of xi plus f of xn, right? This value I have evaluated by this function. So now the same trapezoidal rule, if I have to apply here, okay, for n intervals, so I can apply. So this is my trapezoidal rule for n intervals, okay? This is the trapezoidal, but for the 2 points, trapezoidal, this is trapezoidal rule for n intervals, correct? N intervals. Now here in our question, if you look at the question, okay, so there are just two intervals there, right? So it is from 0 to 1, even if I apply a to b. So a point is 0 and b point is 1. So it is just between a and 2 points are there. So 2 points trapezoidal rule is this h by 2 and f of a plus f of b. I'm just calculating the area of it. So I know that my f of 0, that is nothing but my f of a, happens to be my e power 0, because my function f of x is e power x dx, right? 0 to 1 e power x dx, right? So here my f of x is nothing but e power x, right? So f of 0 would be equal to my e power 0. Anything to the power 0 would be 1. Same way, my f of b would be equal to, tell me, f of b would be equal to f power 1, because b is 1. So it would be e power 1. If I put in the calculator, I find out this is 2.718, right? This is 2.718. If I move to the next slide, so I just substitute these values. H function, I know b minus a by 1. So B is 1, 1 minus 0 by 2. So my H value happens to be zero point 0.5 or 1 by 2. E power x dx. So this would be half. And then I just substitute the value back, f of a plus f of b. F of a is 1. I saw that this is 2.718. And if I go through this, this is half into 3.718. Okay. This happens to be 1.859. But, and I'm getting this answer. But if I do analytically this question, analytically 0 to 1 e power x dx, integration of e power x is e power x. So it would be 1 and 0. So here the value is e power 1 minus e power 0, right? So this value happens to be e power 1 minus e power 0 is minus 1. So this is 2.718 and this happens to be 1.718. But if you see, the trapezoidal rule is slightly overestimating it. Trapezoidal, okay, rule, rule overestimates the value slightly here. Okay, slightly here. Okay, so this is all about this question. I think you might have understood. This has come for the 10 marks in the exams. I hope this you have understood.